Welcome to a short presentation about research we are performing at Dignitas Technologies to develop an alternative software architecture for the Navy's portable electronic maintenance aid devices, which are also known as PEMA devices. PEMA devices are used for aviation maintenance at Navy facilities around the world. Other services, such as the Air Force, also use similar PEMA devices. Our research to develop an alternative software architecture for PEMA devices is performed under a Small Business Innovation Research, or SBIR program under the Small Business Administration. We are currently executing Phase 2 of this project under the direction of the Naval Air Systems Command. Dignitas Technologies is a woman-owned small business based in Orlando, Florida. We support modeling and simulation, training development, and sustainment across the Department of Defense. Our technical focus encompasses systems engineering, including architectures, design, development, and full lifecycle system software development. Dignitas has a significant history with SBIR awards. We have had 20 Phase 1 awards since 2008, and we have supported 45 Phase 1, 2, and 3 SBIR contracts over the past 14 years. We are focused on transitioning our SBIR research to usable products for DoD and commercial customers. We have had 9 Phase 3 transition-focused contracts, with $13 million in funds. For example, our Phase 3 SBIR, the Cyber Battlefield Operating System Simulator, or CyberBOSS, incorporates cyberspace actions and effects into synthetic training environments, and was nominated for the 2022 Tibbets Award. Dignitas has 2 facilities, totaling approximately 35,000 square feet of space, near the University of Central Florida and the Central Florida Research Park, including a technology development, integration, and test laboratory. Our staff includes experienced innovators as principal investigators of successful SBIR programs. We have broad technology expertise in areas such as operating systems, software containerization, cybersecurity, software development, machine learning, and artificial intelligence. We are the prime contractor on many DoD efforts, including the Navy Advanced Computer-Based Training Systems, the Army Digital Integration Lab, and the Live Virtual Constructive Integrating Architecture. So let's discuss the challenge we are trying to meet with this research effort. Currently, Navy PEMA systems employ the Microsoft Windows 10 operating system, which requires application of frequent, large patches and complex licensing requirements. This is particularly challenging since PEMA are often used in standalone or closed-loop configurations. The Navy is looking for an alternative open-source software-based PEMA to reduce maintenance burden and costs. An additional complication for PEMA systems is that they have to support many Navy Type Model Series, or TMS, aircraft using a common system for all environments and platforms. PEMA run numerous applications, some specific to certain TMS, and the bulk are Windows-based applications with a lack of funding to convert to Linux. To provide continued support to the Windows-based applications and to reduce application conflicts, the alternative architecture must support virtualized or containerized applications. It is clear that management of the various configuration of PEMA devices requires a flexible, composable architecture. This research has a clear transition target which includes Navy acquisition programs in air platform maintenance and information systems. Similar programs in the Air Force or other services are also strong targets for this technology. Additionally, this technology development would benefit commercial applications supporting austere environments that require maintenance applications hosted on a ruggedized platform. There are 3 Navy requirements this research is focused on. The first requirement we are addressing is reducing the frequency and volume of ongoing software vulnerabilities and related requirements for software patch updates. This effort must be faster and less costly than the current processes under Microsoft Windows 10. Second, we must support containerized applications to provide a long-term, sustainable solution to support a variety of TMS applications on a common PEMA hardware device. Finally, we must be able to run existing Windows-based applications, PEMA applications, without the need to convert them to the Linux operating system, which would be an expensive and time-consuming task. Let's talk a little more about the PEMA systems. PEMA are maintained by the NAV Air Common Aviation Support Equipment Program Office and are used in direct support of weapon systems to perform maintenance, inspection, fault diagnosis, and repair tasks. The PEMA Navy customer base consists of hundreds of organizational, intermediate, and depot maintenance activities. PEMA systems serve as the host for applications and documentation used in aircraft maintenance, including interactive electronic technical manuals, the automated logistics environment, and diagnostic applications. The current Windows 10 PEMA baseline requires 20 gigabytes for a clean install and continual patching, with patch sizes often exceeding 1 gigabyte. Additionally, maintaining TMS-specific applications on the current PIMA baseline brings significant maintenance and security burdens. The goal of this research is to develop technology that will reduce the time and cost for PIMA patching and licensing over the existing baseline and promote customized PIMA deployment to meet TMS program needs. Through our research, we are developing a product called the Secure Modular Architecture for Ruggedized Technology, or SMART. SMART is an open-source software-based PIMA alternative architecture. There are 3 goals of the SMART product. First, it will reduce the time and cost of patching compared to the current Windows-based PIMA system. Second, it will increase automation for patching and control of PIMA systems in austere closed network environments. Finally, it will improve support for customized PIMA deployment to meet needs of Navy TMS programs. In this research, we are defining the SMART architecture utilizing Red Hat Enterprise Linux, or RHEL, Podman, and Ansible. We are developing a toolset and processes for PIMA AA system patching under RHEL 8, and we are using Podman containerization to deploy PIMA applications such as the NAV Air Standard IETM Viewer, or NCIV. The SMART architecture will significantly reduce the manpower and costs for PIMA patching and improve PIMA customization for Navy programs. It provides several advantages over the existing Windows 10-based system. First, RHEL is customizable to PIMA needs, reducing the software load on the device. It has a smaller footprint than Windows 10, reducing the number and size of required patches, and decreasing patching manpower and cost. Second, using Podman software containerization provides a more flexible environment for TMS application development, improving PIMA customization for Navy programs. And finally, use of Ansible provides superior tailorability to support new PIMA applications and requirements. Ansible integrates with enterprise tools to reduce time and cost of PIMA deployment. Here is a timeline of our PIMA AA research effort to give you an idea of where we are in the process. Dignitas was awarded a Phase 1 SBIR at the end of 2020, and we were awarded a Phase 2 SBIR at the end of 2021. Our Phase 2 effort extends to the end of 2023. We plan to pursue additional funds, potentially with a Phase 3 SBIR, to allow further development of SMART and transition to end users within the Navy and other services. Transition of SMART to the fleet will involve further testing and evaluation of the SMART platform beyond our Phase 2 work. This will include demonstrating the ability to support PIMA users and administrative functionality and containerized TMS PIMA applications. We will support risk reduction testing and operational testing, procurement, and pilot fielding to a squadron for evaluation of the SMART prototype. We will also support the transition of unique PIMA TMS solutions to operate within our SMART architecture. Our primary transition advocate is the PIMA program of record. Other transition advocates can help us identify programs with similar needs as transition targets. The SMART solution can benefit other secure systems operating in austere, closed network environments. The technology we are developing for SMART can benefit other DoD and commercial applications supporting austere environments with limited capacity for licensing and maintenance tasks. Other DoD organizations and private companies can employ this solution to reduce costs related to software licensing as well as reduce costs related to ongoing requirements to maintain a strong cybersecurity posture throughout the lifecycle of a system. Other DoD markets applicable to SMART include other applications within the Navy that deploy ruggedized platforms for system maintenance in closed network environments. It also includes other services that use PIMA systems for aircraft maintenance in austere environments. SMART is potentially applicable to other types of DoD systems that require security patching and licensing and variable configuration deployments in specialized environments, such as mission command systems and training systems. Commercial markets for SMART include private sector environments such as commercial aircraft maintenance. Our initial transition focus for the SMART technology are the Navy's PIMA devices, and we plan on supporting the transition from a Windows 10 environment to the SMART architecture. We will also provide support for deploying PIMA applications using software containerization, including working with program offices for PIMA applications and other primes for development, maintenance, or sustainment of PIMA applications. To fund these transition activities, we are looking for funding sources such as Phase 2 sequential or Phase 3 contracts or naval customer-directed funding. We are also considering secondary transition targets as additional funding sources, including program offices for Air Force PIMA devices, Army maintenance support devices, and Army Mission Command Information Systems. Thank you for your interest in our research to develop the smart architecture for providing a more rapid, cost-effective system for maintaining secure, ruggedized hardware within austere environments. For more information, please reach out to the contacts listed here.